Number 6. Suppose that F 1000 Newton mass 1 3 kg, mass 2 15 kg, and M3 30 kg. Determine the acceleration of block system. B. Tension of the rope T1, T2. Okay, for question A, acceleration of block system. Okay, that means this block system accelerate. So we have to use Newton's law, net force X equals to ma, and because it is accelerate at X component. Okay, it is pulled by force F to the left. That means the acceleration is to the left. Okay, acceleration is to the left, and it is at X component. Okay, and for Y component, it is in equilibrium. It doesn't move at Y component. Okay. So for this system, we have only force F. Okay, force F. Okay, single force F push force to the left, and it is in same direction with A, so it is positive. And then so it pull M1, M2, and M3. Okay, so these three masses, okay, these three masses will move with same acceleration A. Okay, so substitute F 1000 Newton, substitute M1 3 kg, M2 15 kg. Mass must be in unit kilogram. Okay, 30, and then A is the unknown that you have to find. So acceleration A is, okay, it is 1000 divided with 3 plus 15 plus 30 equals 20.83 meter per second squared. And then for question B, tension of the rope T1 and T2. So for this one, we have to solve by object. Okay, so we have three objects. Okay, M1, M2, and M3. So we will have three free body diagram. Okay, we will have three free body diagram. So for M1, it has force F to the left and T1 to the right. Okay, so free body diagram for M1 is T1 and F, where the acceleration is to the left. Okay, acceleration A is to the left, so we can apply net force X equals ma. So force which the same direction as acceleration is the F. So F will be positive. Okay, look at the arrow. And T1 is opposite direction of acceleration A. So it is negative. Okay, so F plus negative T1 equals to M1A. Okay, so F is 1000 minus T1 is the unknown, and M1 is 3 kg. A already calculated 20.83. So T1 equals 20.83 times 3 divided with 1000. No, minus 1000. Okay, so it is equals to 937 1000 minus 3 times 20.83. So it is equals to 937.5 Newton. Okay. So T1 equals 1000 minus in bracket 3 times 20.83. So it equals T1 equals 937.5 Newton. Okay, and then how about M2? Okay. Okay, look at this diagram. So M2 has T1 to the left and T2 to the right. Okay, so T1 to the left and T2 to the right. Okay, tension must be away from object where the acceleration is to the left. Okay, so we can apply net force X equals to MA to M2. Okay, so T1 is the same direction as A, so it is positive, and T2 is opposite direction of acceleration A, so it is negative. T1 minus T2 equals to M2A. T1 already calculated, it is 937.5 minus T2, and M2 is 15 kilogram. A already calculated 20.83, so T2 equals to 937.5 minus in bracket 15 times 20.83. So it is equals to 625.05 Newton. Okay, 625.05 Newton. So we already get value of T1 and T2. Okay, so if you want to use M3, for M3, okay, it's only have T2 to the left. Okay, T2 to the left, where acceleration is to the left as well. So we may use net force X equals to MA. Okay, so T2 equals to M3A. Okay, so M3 is 30 kilogram and acceleration is 20.83. So T2 equals to 30 times 20.83 equals 624.9 Newton. Okay, it is the same as we calculated from M2. Okay. Okay, this concept is you may use M3 or M2, doesn't matter. Okay. Number 7. Two object masses M1 50 kilogram, M2 150 kilogram are tied to a light string. Okay, this is a string and at rest on smooth horizontal floor as shown in figure. Okay, determine the horizontal force P. Okay, this is the horizontal force P. Okay, force P acting on one object so that the acceleration of both objects is 4 meter per second squared. So for question A, okay, we can solve this problem by consider M1 and M2 as a one system. So net force X equals to MA. Okay, so it has only force P. Okay, force P to the right and force P force P, it pull M1 and M2. So both M1 and M2 will accelerate with same acceleration. Okay. So force P is the unknown that you have to find. M1 is 50, M2 is 150, and the acceleration is 4. So force P equals to 50 plus 150 times 4. So it is equals to 800 Newton. Okay. And then B, the tension in the string connected the two objects. Okay, so for this one, we can consider either M1 or M2 object. Okay. Okay, question B. Let's say we consider M1. Okay, for M1 only. Okay, consider by object. So M1 has normal force at Y component and weight M1 at Y component, and then T, okay, away from M1 because it's connected to the string. Okay, so it is accelerate, so we can use concept net force X equals to MA, accelerate at X component. So okay, it's like this: normal, weight, and T, and it is accelerate to the right. Okay, so force at X component, which is the same direction as A, is T. So T is positive. So T equals to M1A. So T equals to M1. M1 is 50 and A is 4. So tension is 200 Newton. Okay. So, or maybe you can consider for M2. Okay, consider for M2. Okay, so for M2, it has normal at Y component and weight 2 at Y component as well, and force P at Y component, and T FP as at X component and T at X component. Okay, let us draw free body diagram for M2. So it has force P to the right, tension away from M2, weight of MP, and the normal of MP. Okay, so it is accelerate to the right. Accelerate to the right. Okay, so we may apply net force X equals to MA. Okay, so FP is the same direction of A, so it's positive, and T is opposite direction of A, so it is negative. Okay, so FP is 800 minus T is the unknown, and then M2 is 150 and acceleration is 4. So T is equals 150 times 4, 800 minus 150 times 4. So it is equals to 200 as well. Okay, value T is the same because it's the same string. Okay, but tension for M1 is away from M1, and tension for M2 is away from M2, but their magnitude is the same. Okay, the magnitude T is the same because this is the same string. Okay. Okay, Is the normal force N for M1 is the same as normal force for M2? No, they are not the same. Okay, because normal force for M1, okay, normal force for M1 is depend on weight 1, okay, and normal force for M2 depend on weight 2. Okay, it is from net force Y equals to 0. Okay, net force Y for M1, net force Y equals to 0. So N1 minus W1 equals to 0. So N1 equals to weight 1. And for M2, okay, net force Y equals to 0. So N2 minus weight 2 equals to 0. And 2 equals to weight 2. So normal force for M1 is not equals to normal force for M2. Number 8. Two objects of masses M1 10 kg and M2 15 kg are connected by a light string which passes over a smooth pulley as shown in figure. Calculate the acceleration of the object of mass 10 kg. So actually, acceleration of object of mass 10 kg is the same as the acceleration of object of mass 15 kg because they are in the same system. Okay, and then B, the tension in each string. Okay, tension in each string. So actually we only have one rope or one string. Okay, we only have one string. It is the same string. Okay, that means the tension is the same. Okay, so for this problem we have to consider by object. Okay, so for M1, okay, so for M1 it has T tension and it has weight 1 of course. Okay, and then it is accelerate upward. Okay, look at the arrow. The arrow represent the direction of acceleration upward for M1 because M1 and M2 in the same system. If M1 accelerate upward, then M2 will accelerate downward. Okay, it is synchronized. Okay, because they are in one system. Okay, for M2 it has tension. Okay, the same as tension for M1, and then it also have weight 2. Okay, let us solve by object. Okay, for M1, okay, so it has tension and weight 1. Okay, and M1 accelerate upward. Okay, like this, accelerate upward. Okay, then we can apply Newton's law. Net force Y equals to 0. Okay, it is accelerate at Y component. Net force Y equals to ma. So T is the same direction as A. Look at the arrow. Okay, arrow of A is upward and arrow T is upward, so T is positive for M1. So T minus weight 1 opposite direction of A, so it is negative, equals to M1A. So simplify, weight 1 is M1 times G. Okay, so M1 is 10 kilogram. Okay, 10 times G 9.81 and then 10A. Okay, so we can simplify. So it is equals to T minus 98.1 equals to 10A. So we have two unknown in this equation. Okay, and then proceed to M2. Okay, proceed to M2. So for M2, look at M2. M2 we have tension upward and W2 downward. Tension upward and weight 2 downward. Okay, and the acceleration for M2 is downward. Okay, acceleration is downward for M2. Next, we can apply net force Y equals to MA for M2 because it is accelerate at Y component. It is accelerate at Y component. Okay, look at the arrow of weight 2 and A. It is the same, so weight 2 will be positive. And look at the arrow of tension and A. It is opposite, so tension will be negative. Okay, weight 2 minus tension equals to M2A. Then we can simplify. Okay, mass 2 is 15 kilogram. G is 9.81 minus tension equals to 15A. Okay, simplify 15 times 9.81. So it is equals 147.15. Okay, minus tension equals to 15A. So we have second equation with unknown T and A. So the rest is mathematics. So either you can substitute equation 1 into equation 2. Okay, and then we can get the value of A. Okay, so from equation 1, okay, maybe we can let T be the subject. Okay, maybe we can let T be the subject. So T equals to 10A plus 98.1. So substitute equation 1 into equation 2. Okay. Okay. 147.15 minus T, which is T is 10A plus 98.1 equals to 15A. Okay, so it will be like this, negative 10A. Okay, 147.15 minus 98.1 equals 49.05 equals to 15A. Then we can get the value of A. Okay, so 49.05. Okay, divide with 25. Okay, so it is equals to 1.692 meter per second squared. And then the T, okay, the tension T is maybe from equation 1. Okay, T equals 10A. Okay, from equation 1. Okay, T equals to 10A, this one. Okay, 10A, A is 1.692. Okay, plus 98.1. So T equals 117.72. 117.72 Newton. Okay, so we already calculated the tension and the acceleration of the object, of the two objects. Okay, it's not the acceleration of 10 kilogram object only, but it's also the acceleration of the object of mass 15 kilogram. Okay. Number 9, two objects A and B are connected by a light string. A mass of 20 kg lies on rough horizontal surface. Okay, so this is the surface, the rough surface. Maybe object A on a table. Okay, while B of mass 4 kg is suspended in air. As shown, B is released from rest and both objects start to move. Okay, a friction force of 4 Newton. Okay, so this is the frictional force 4 Newton acts on the A. Okay, because only object A in contact with the rough surface, but object B is not in contact with that surface. Okay, determine the acceleration of each object. So acceleration of object A and B will be the same because they are in the same system. Okay, and then B, the tension in the string. Okay, so let us draw all the forces acting on object A. So for object A, it has weight, of course, and then it is in contact with surface, so it has normal force 90 degree to the surface, and then it has friction, opposite direction of motion. As you can see, there is an arrow, okay, here. So this arrow here will represent the direction of the motion. Direction of the acceleration is to the right for object A. So when object A moves to the right, so object B must be moved downward. Okay, it should be synchronized. Okay, because they are in the same system. Okay, and then object B connected with strings, so it has tension away from object B. Alright. Okay, how about object B? So for object B, the forces acting on object B is the weight itself, okay, downward, and then the tension, because object B also connected to the string, so it has tension away from the object B. So tension on object B is equals to tension on object A because it is the same string. Okay, so they have same magnitude of tension, but tension on object A is away from object A, but tension for object B is away from object B, and tension is along the string. Okay, so let us solve one by one. Okay, maybe we can draw free body diagram for each object first. Okay, so for object A, it has normal and weight. Okay, this is the force on vertical, and then it has tension to the right and friction to the left. Okay, and object A, object A move to the right. Okay, object A move to the right, accelerate to the right. Okay, so concept for object A, net force X equals to MA because it is accelerate to the right and it doesn't move at Y component. So for Y component for object A, his net force Y equals to 0. Okay. So for object A, okay, object A, for X component we only have friction and tension. Okay, friction and tension. So tension is in the same direction of acceleration. Okay, so tension is positive, and friction is opposite direction of A, so friction is negative. So it will be tension minus friction, or tension plus negative friction, equals to ma, where m here is the mass of object A. Okay, so T minus friction equals to mass A times acceleration. Okay, T is the unknown. Okay, and friction is already given for Newton. Okay, mass object A is 20 kilogram. Okay, 20 A. Alright. So for component Y for object A will be n plus negative weight object A equals to 0. Okay, this component. Okay, this one. Okay, for Y component, n and weight A. Okay. Okay. So normal equals to weight A, where weight equals to mass times gravity. Okay, mass object A times gravity. But we don't use this component because the frictional force is already given. Okay, the friction is already given. The value of friction is already given for Newton. But if the question only give you the mu, the coefficient of friction, okay, if mu is given, so you have to determine friction by using formula friction equals to mu times normal. So normal can be determined from component Y. Okay, but for this question, we don't use that component Y for object A because we already get the value of friction. Okay, of frictional force is already given. It is for Newton. Okay, so we have first equation. Okay, equation 1 with two unknown, which are tension and acceleration. And then proceed to object B. Okay, for object B, okay, maybe we can draw free body diagram for object B. So for object B, it has weight B vertically downward and tension upward, and the object B accelerate downward. Okay, accelerate downward. Okay, because object A move to the right, so object B must move downward. Should be synchronized. Okay, because they are in same system. Okay, so let us apply Newton's second law for object B. So because object B accelerate at Y component, so net force Y for object B is equals to ma. Okay, so look at this. Weight B is in the same direction of acceleration, so weight B is positive, and tension is opposite direction of acceleration, so tension is negative. So for net force component Y will be weight B minus tension equals to mass B times acceleration. Okay, so weight B is mass B times gravitational acceleration minus T equals to, okay, mass B times A. Okay, so substitute mass B. Mass B is 4 kilogram, and then times G is 9.81. minus tension equals 4A. Okay, so maybe we can simplify. 4 times 9.81 equals 39.24. 39.24 minus tension equals to 4A. So we have second equation with two unknown, which are tension and A. So the rest is mathematics. Okay, the rest is mathematics. For you to determine tension and acceleration. Okay, so maybe from equation 1, okay, from equation 1, you can let T be the subject. So T equals to 20A, 20A plus 4. Okay, so substitute T equals to 20A plus 4 into equation 2. Alright, so we can proceed. 39.24 minus 20A plus 4 equals 4A. Now we have one equation with one unknown, so we can determine the value of A. Okay, 39.24 minus 4 equals 35.24. Okay, negative 20A equals 4A. So 35.24 over 24. So it is equals to 1.47. So A equals 1.47 and unit for A is ms negative 2. Okay, so we already calculate acceleration of object A and object B. They accelerate with same acceleration because they are in the same system. Okay, how about tension? Okay, so for tension T, we just simply substitute A. Okay, 1.47 into equation 1. Okay, plus 4. So tension equals to 33.37. 33.37 and unit for tension is Newton. Okay. Number 10. Two forces act on an object of mass 2 kg, which is placed on smooth horizontal surface. Okay, that means there is no friction as shown in figure. So we have 10 Newton and 6 Newton of forces acting on this object. So we have to calculate the acceleration of this object. Okay, so the concept is net force X equals to ma, because this object accelerate at X component. But then we have to draw all the forces acting on this object. So this object have weight downward and the normal force. Okay. And then force 10 Newton tilted 30 degree to the horizontal, and for 6 Newton tilted 45 degree to the horizontal. So these two forces should be resolved, okay, to X component. Okay, let's say this is the F1. Let's say 10 Newton is the F1 and 6 Newton is the F2. So we have to resolve F1 to F1X and F1Y. and then we have to resolve F2 to F2x and F2y. Okay, so for component x, it accelerate to the right. Okay, accelerate to the right. So the concept is net force x equals to ma. So look at this area. Okay, so we have F1x and F2x. Okay, we have F1x and F2x, where F1x is in the same direction as A, so F1x is positive, and F2x is opposite direction of acceleration A, so F2x is negative. So it will be F1x plus negative F2x, okay, equals MA. F1x, we have to relate with F1 and angle 30 degree. So it is F1 cos theta, and then F2x is F2 cos theta equals to MA. So F1 is 10 and theta is 30 degree. F2 is 6 Newton and theta is 45 degree, and M is 2 kilogram, and acceleration A is the unknown that you have to find. Okay, so 10 cos 30 degree minus in bracket 6 cos 45 degree divide with 2, so it is equals to 2.21 meter per second squared. Okay.